Good morning, my dear friends. So now, in the last class, we have seen for the problem given how to go for the preliminary day design. Am I right? Now we shall go for the final day design. Okay. So now, as you know, the final day design is made by allowing no tension in the section. In the sense, I am not going to allow any tension in the concrete. So now, for the required for the selected I section, okay, we have got AC is equal to 21000 mm square. Is right or no? This is the provided area of concrete 21000 mm square. Okay, so now for the cross section, whatever you have given I section, okay, no, I section is now here, as you know. Okay, for this you try to calculate your moment of inertia. I think it can be now done easily. Moment of inertia, okay, is now can be now easily calculated. It is a 2.32 into 10 to the power of 10 mm fourth. Baba, while calculating the moment of inertia, what I have done is now, okay, I am considering this as one rectangle. This one rectangle. From this rectangle, I have deducted these two rectangles. This one rectangle, this is another rectangle. These two rectangles I have deducted. Okay, so either you can do that, or otherwise you individually you go for. Okay, both the things can be now done. So I can be now easily calculated. It is 2.32 into 10 to the power of 10 mm fourth. Also, once I know I and AC, I think R square can be now easily calculated. It is I by AC. So I you know, AC you know, R square can be now calculated. Okay, and you know that YT and YB are 450 mm. Okay, so now I think I can easily calculate my KT and KB. KT and KB is given by R square by YT or R square by YB. So since YT and YB values are same, okay, your KT and KB values also will remain same. So R square I know, YT or YB I know. So its value is now 245.5 mm. Okay. So now we'll try to calculate this E minus KB value. Okay, E minus KB value is given by MD by PI. Am I right? So MD I know divided by PI I know. It is the initial pre-stress. So it is now 105.67 mm. So now once I know this E minus KB value as so much, I think E value can be now easily calculated. Okay, from this equation, E is now 105.67 minus plus KB. KB I will take this side. Okay, so now KB value I know. Okay, so eccentricity can be now easily calculated. So eccentricity is now 352 mm. Okay, so now this 352 mm eccentricity is available in our provided section. Okay, see now I will show you our cross section provided is like this now. Is it right or not now? Your YT value is 450, YB value is also now 450. So eccentricity, these were CGC. Am I right now? These were CGC. So from here, 352 mm eccentricity, if I come down, it will be well within the section. Somewhere here it will lie. Am I right now? 352 mm. Okay. So now your eccentricity lies well within the cross section. Am I right now? So I have said here now, this 352 mm eccentricity can be provided in your section. Okay, that's one thing. So now, uh, but now, so now, so now our eccentricity is now 352 mm. So now by using this eccentricity, now I would like to calculate my effective pre-stress required. Now this is your re-estimated effective pre-stress. Am I right now? It is a new value of your effective pre-stress. It is given by MT divided by E plus KT. Am I right now? So MT I know, eccentricity I know, and KT value I know. Am I right now? So now our new estimate of pre-stress, effective pre-stress is so much. Okay. So this only I have to now consider for all my next calculations. Okay. This is now new effective pre-stress. So now once you know your effective pre-stress, I think I can easily calculate my initial pre-stress Pi, Pe by eta will give me the initial pre-stress. Okay, so this is our new estimation of our initial pre-stress. Okay, now also now at the transfer of pre-stress or in the initial condition, AC required is given by AC is equal to excuse me, sorry. See now, at a transfer of pre-stress or in the initial condition, AC required is given by AC is equal to PID divided by FCCIYT. All the values are known to me. I know, initial pre-stress, overall depth I know. This is one FCCI value. In sense, it is the this thing allowable compressive stress in initial condition. You know that its value is 15 given in the problem. YT value also I know it's as 450. So but now AC required in the initial condition is so much. Am I right now? But we have given an area of concrete as 21000 mm square. So I have given more area than the required. So I say that the provided cross section is safe in initial condition or during the transfer of pre-stress. Okay, so now similarly I want to calculate area of concrete required in the working condition or in the final condition. Okay, it is given by AC is equal to PED divided by FCCF YB. Okay, PE I know, it is the effective pre-stress required. D I know. Okay, and FCCF value also I know, it is 13. YB value also I know. So but now the AC required is 195,100. Okay, so much, and we have given an area of so much. I have given more area than the required. So I say that okay, the provided area is safe in working condition also. So now both in working condition as well as in initial condition, my area provided, area of concrete AC, is okay or is safe now. Okay, so now we shall try to calculate now how much area of steel is required. Okay, so now area of high tension area of steel is given by Pi divided by allowable tensile stress in steel. Okay, Pi is your initial pre-stress. Okay, this divided by allowable tensile stress in steel will give me area of steel. Okay, so now Baba, in the problem he has given the ultimate strength of the wire. Ultimate strength of the wire he has given it as 1700 Newton per mm square. Okay, so now here is a clause, you just I will read it. The maximum allowable tension in steel should not be greater than 60% of the ultimate strength. In a sense, if at all you want to calculate this allowable tensile stress in steel, it is the 60% of your ultimate strength. Okay, so now I will try to calculate the allowable tensile stress in steel. Okay, it is a 60% of your ultimate tensile stress. So ultimate tensile stress is given in the problem as 1700. Okay, so 60% of this will give me 1020 Newton per mm square. In a sense, 1020 Newton per mm square is your permissible tensile stress in steel or allowable tensile stress in steel. Okay, so now I think I can easily calculate the area of tension steel. Okay, it is Pi divided by allowable tension. So Pi I know, it is so much, and allowable tensile stress in steel is so much. Okay, so it will give me 1526 mm square. In a sense, I need this much area of steel. Okay, so now I'm going to use 6 mm wires. So area of one 6 mm 5 wire is given as pi d square by 4. It is 28.26 mm square. Okay, therefore number of wires required, it is capital AT by small at. Okay, so 1526 is the total area of steel required, and area of one wire is so much. So it will, I need 54 number of wires. 54 wires are required of 6 mm. Am I right? So now I say, so 50 in this 54 wires, I say that provide 6 cables with 9 wires per cable. Am I right? 9, in sense I will make 9 wires bundle of 6 cables. Okay, so that it will, in sense, 6 cables I am going to provide in the I section. Okay, this is how design can be now done. Okay, thank you very much. Thank you.